Hello everybody, yes we are back again and we're going to talk about sound. Now today we're going to talk about loud and soft sound. Let's dig in. Now today's learning outcome is we're going to investigate how sounds can be loud or soft. So how do you think we can test those type of things? Now what do you need to know after today? Why are some sounds loud and others soft? What's the reason behind it? What's the science behind it? Now, first of all, words we need to know. We need to know what is loud. So, for example, loud means like a sound like an alarm clock. When it goes off, loud sound. So it's so loud it actually wakes you up. Okay, and then soft. What is soft sound? Okay, it's a sound like a whisper. So it's not a very, very loud sound. It's very soft, to be honest. Okay, now let's play a game. Sort the following sounds if it's loud or is it soft. So if I say thunder, ooh, will that be a loud sound or will that be a soft sound? What do you think? And yes, it is a loud sound. It is a big sound. Okay, and what about this one? Will the bell be a loud sound or a soft sound? It is a loud sound. Yes, you are correct. What about this one? Ooh, a heart beating. Will that be a loud sound or will it be a soft sound? Yes, it is a soft sound. You can't hear your heartbeat all the time. So, but maybe sometimes when you're scared or you get a fright or you're shocked, then it feels like your heart is pounding and things like you can hear it. But the person next to you can't even hear it. Okay, so it's a soft sound. What about this two? Whispering. Is it a loud sound or is it a soft sound? Let's see. Yes, it is a soft sound. Well done, guys. Let's have one. Ooh, what is this one? It's an ambulance. Ambulance. So what will that be? A loud sound or a soft sound? Yes, it is a loud sound because it needs to be loud. So when we are driving our car, la 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 la, we hear ambulance and we know we need to give way. Okay, so that it needs to be a loud sound that everybody can hear. Listen here, move out the way. There's an emergency. We need to go and help. Okay, what about a bee? Will that be a loud sound or a soft sound? Yes, it is a soft sound. I think that is one of the easiest ones there. Okay, yes, sometimes you can hear it, but it's not that loud. It is actually a very soft sound. Well done, guys. Great job. Yes, guys, now it's our time for our little experiment. We're going to do activity 4.4a. And what we're going to need for today is my ticking clock and a long cardboard tube. Now, last time we used some plastic wrap that you find in your mom's kitchen. But if you have a look, yes, there it is. That's my tube. So we're going to use this tube actually for this experiment as well. So first thing we need to do is hold the clock next to our ear. So I'm going to use the back side of the mechanism because that is where actually the ticking will be louder. So it's for me easier to hear. Can't put ears. Okay, but let's do it. Oh, can you hear that? Okay, so yes, we can hear it. Okay, so it's loud, it's clear. I can hear tick, tick, tick as the seconds goes away. So what we need to do next in our activity? Okay, now hold the clock away from your ear. Okay, so we're gonna hold it not closer. We're gonna move it away. I can hear it. Okay, so yeah, let me talk. So clearly we can still hear it, but it's not as loud as before. So let's see, what do we need to do next? Now, before we're going to go on with the next step of this experiment, we need to know what's the science about it. Okay, now as you move the clock away, the vibrations travel in all directions. So if I have a look, for example, this clock, if is not always just moving straight forward. It's moving in all directions of the clock. So what actually happens as well, the distance it needs to travel increases. So it was, when it was first close to my ear, it's very close distance the vibrations needs to move or travel. Okay, but when I keep it a little away from my ear, the travel distance get longer. So it takes a little bit longer, and it's also going to get a little bit softer. So if you think about it, when you drop a stone in water, as the ripples move further away from where the stone was dropped, it starts to spread out, and the distance between the waves actually gets bigger, 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 bigger. And that's the same with sound. Okay, as it moves away from the source of that sound, it actually starts spreading out the waves, and that means it's actually getting softer. Now, the next part of our experiment is we're going to use the tube and we're going to use the clock. So I'm going to hold it one side of my ear and the other side the clock. Oh, that is clear. Okay, now was the sound soft, louder or softer? Why do you think this happened? Let me see if I can help you guys. Okay, was it louder? Was it clearer? Let's. So what's the science behind this? Why suddenly when I use the cardboard tube and hold it against my ear and the clock still away from my ear, it's suddenly louder? Like it's almost like the clock is next to my ear. The reason for this is the sound waves, that vibrations are being trapped, and it doesn't move in all directions. It actually are being trapped and only sent in one direction. Okay, and for this reason it will be a louder sound, because the vibrations are not spreading out so much quicker, but it's actually staying closer because there's a lot of vibrations moving in one direction. Now, this technique was actually used long time ago, before we have these hearing aid pieces that we can put in our ear. Now, as you can see in this photo, it is actually the same. It's like the cardboard, but it's a bigger opening because it actually collects more vibrations in the air, and then it channels and traps it down in the little tube to the person's ear, so that those vibrations are getting concentrated, so to say, and closer to one stack, so that the person can actually hear what you're saying. Not too shabby for old people, hey? Okay, so let's see if you learned something today. Why are some sounds loud and others soft? Okay, it's all about vibrations, and vibrations. Remember, the bigger vibrations make louder sound. And if you have a smaller vibration, it makes a softer sound. So that is the reason why we have difference in loudness and softness of a sound. So, and as well, when we trap the sound vibrations, it actually helps us to make the sound louder, but it's actually, we're actually concentrating our vibrations. Okay guys, now what you guys need to do for me now is, first of all, you need to complete exercise 4.4 in your activity books, and then also on Moodle you can find complete worksheet 4.4a, and then you also submit it back to me in Moodle so I can check that you understand. Guys, that is all from me today. I'm going to say goodbye, and hopefully I'll see you guys soon, and to learn a bit more about sound. Remember what we've learned today? Sound can be loud or soft, but it depends on the vibrations. If it's a big vibration, it's loud. When it's a small vibration, it is soft. Okay, see you guys. Enjoy your day. Goodbye.